Hello. Welcome to studentlearning.in, your e-learning buddy. Welcome back to our channel, guys. If you are new to this channel, please make sure to hit the subscribe button and press the bell icon to join the family.
Today class session is based on big data for life science. So there are numerous agenda of these sessions like history of data in healthcare, advantage of big data with life science, big data in healthcare, big data with Alzheimer's diseases, big data with diabetes, types of medical data, future of big data in life science, big data analytics in healthcare, and structure of big data in life science. So first one, I'm going to explain history of data in healthcare. So there is a previous history of data in terms of healthcare. Like first, there is a Microsoft Excel monitoring spreadsheet. Microsoft Excel is a combination of row column arrangement. After that, there is an electronic health record. Electronic health record is also known as EHR records. After that, there is a system. The system is called RDBMS, that means Relational Database Management System. RDBM is a collection of database is a collection of tables, table is a collection of rows and columns. After that, there is intelligence, the intelligence called business intelligence, and after there is a comparative effectiveness research, and then clinical operation intelligence, and then public health analysis. These are history of data in healthcare. So there are numerous advantages of big data with life science, like it is time convenient, almost any disease can be detected. Next one is deadly diseases can be detected at early stage. That is the most powerful advantage of big data. Next is it will reduce the crowd in health centers. That means with the help of big data, we can easily reduce the crowd and population of health center or medical centers. Next is customer satisfactions. Privacy of the patient will be maintained. That means with the help of big data or with the help of big data with artificial intelligence, we can maintain the privacy of the patient. Next is patient can have multiple options of treatment like allopathic, Ayurvedic and homeopathic. This is the additional advantage of big data with life science. The patient will get a diet chart. That means with the help of big data or with the help of data science, we can easily prepare a diet chart of big data. Next, like big data in healthcare. So there is a lot of application in terms of healthcare, like big data with Alzheimer's diseases, big data with diabetes, big data in personalized medicine, and big data in genetics. So first I am going to explain big data with Alzheimer. I think Alzheimer is a very common disease in today's eras. So with the help of big data, it plays a very important role. That means there is a lot of difficulties without big data. So with the help of big data, we can solve all the difficulties and retain of patient in clinical research, and the duration and cost associated with the traditional clinical research are very low. So with the help of big data in Alzheimer's disease, it is still at early stage and more efforts should integrate real world big data to advance Alzheimer's disease research and practice. That means we can reduce cost, time, and all the dangerous side effects of Alzheimer we can easily recover with the help of big data. Next is how to integrate big data with diabetes. So diabetes is a very common in these days. That means the age of 40s or in the age of 50s, diabetes is very common. So we can easily predict or we can generate a MapReduce based algorithms to early diagnose, and on the basis of analysis we can easily generate type 1 diabetes or type 2 diabetes on the basis of big data with diabetes. Next is there is a lot of types of medical data. Like first one is clinical data. Clinical data means it's a medical diagnosis, it's a medical image, patient histories and labs. Second one is omics data. Omics data means it's a genomics, transcriptomics, proteomics, epigenomics and nucleomics. These are type of omics data. Next is claims data. Claims data means data from public and private claims processed across the health system and providers. This kind of data is called claims data. Last is a user generated data. That means there is a lot of apps are available in these days, like fitness apps, data from smartphones. So we can easily collect all the app based data and we can easily generate any medical devices with the help of this kind of data. In these days there's a lot of iPhones, Android phone, there are a lot of health or fitness apps are available in the phone. So we can easily collect data from the phone and generate a proper system to predict any diseases or any treatment of the basis of these apps. Next is very important aspect of life science, that means future of big data in healthcare. So in terms of healthcare, big data is play a very important role. Like in hospital or in medical agencies, we can easily predict any diseases with the help of big data. So there is a real-time visualization. Real-time visualization means that we can easily visualize any real-time data. Real-time data means data can be generated any time, any seconds. That is called real-time visualization or real-time data. That means we can easily predict real-time tracking of health, real-time detection of anomalies, real-time recommendation and automatic urgency detections. And in other prospect, we can generate real-time prescriptions, real-time advice, real-time response and real-time emergencies. So this one is just like as a part of disease surveillance. Disease surveillance is a main factor of medical science or medical devices. So we can generate health data or healthcare data. That means with the help of this healthcare data, doctor will generate patient in the minutes and the steps in the hospitals. That means within 2 to 5 minutes, any doctor easily diagnose the patient. So this one is called real-time interaction with patients. So real-time interaction or real-time visualization is not possible without big data. So with the help of big data or some advanced tools of data science like artificial intelligence or machine learning, we can easily generate disease surveillance and real-time interaction with patient and real-time visualizations. So next is very important part, that is called big data analytics in healthcare. So in these days there is a lot of healthcare data generated and there are many forms like clinical data. Clinical data comes from like medical problems, vital signs, physical exams and medication histories. Second is again very important aspect, that is called imaging data. Imaging data comes from like some types of X-ray machines, some types of X-ray. There's two types. Type 1 like text annotated image data and automatically processed image data. Third one is laboratory data. Laboratory data is very useful aspect in terms of big data analytics with healthcare. Like sometimes data comes from pathology, sometimes data comes from clinical laboratories, and sometimes data comes from proteomics, and sometimes data comes from genetics. So there are these three components like clinical data, laboratory data and imaging data, and combined with a centralized open data systems. And after that, big data analytics work on these kind of data and generate a new diagnosis information, that is called DI. Next is another aspect of big data with like you can how structure of flow of data. That means in terms of drug discovery in life science, there is a phase 1. Phase 1 means create, phase 2 that is compose, phase 3 that means comprehense, and phase 4 that is collection. So phase 1 create means which compound are good for which target. That means we can easily target good compound or bad compound. After that, what disease could be treated with this target. That means we can match, treat with target and drugs. After that, what's the likelihood this compound will succeed? In the second phase, we can compose a structure and we can compose a biological structure on the basis of target drugs or on the basis of compound. In the second phase, that is comprehense, that means it's a key entities and their profile and context. So there are three main RDBMS available or DBMS available in this scenario, that is diseases, targets and compound. So in terms of diseases, that is two tables like organism, pathways. Organism means organism, organ, cell, tissues, pathways like metabolic, genetic, environment, cellular, organism. Similarly, there is another DBMS, another database that is called target. There is two tables, genetic and proteomics. Next is compound. Compound are divided into 7 different tables like IP, drug, physical, toxicity, spectrals, reactions, screening, and there is a lot of variables and a lot of column values in these 7 tables. After that, the last phase, that is collect domain specific content. That means we can generate big data infrastructure with the help of scientific literature and patents, drug and disease ontologies, preclinicals, clinical trials, electronic medical records, lab and imaging data, genomic data, claims data and web social media data. So this one is a proper flow or proper structure of big data with life science. That means create, compose, comprehend and collect. So with the help of this structure, we can easily collect any type of medical data and apply on big data with the help of big data analytics and easily target good drugs and bad drugs with the proper composition.
Thank you so much for watching. Please leave your questions in the comment section down below. Make sure to like, share, and subscribe to Student Learning. Check out more courses from us and follow us on Instagram, Facebook, Twitter, basically everywhere. The link is always in the description. We will be back with more lectures. Stay tuned and have a good day. Bye.